So today we're going to start writing and converting quadratic equations. So your objective is that you will be able to write equations of a quadratic when you're given a point and a vertex, and that you'll be able to convert from standard form to vertex form and from vertex form to standard form. So first, to start, when you're writing the vertex form of an equation, we're going to be given our vertex and a coordinate. So your vertex, if you remember, is HK, which we get from here and here. And then our coordinate is always XY. So we'll be able to substitute in our coordinate for these points and our vertex for these points. But remember that since we have X minus H, it's always the opposite sign here when you're plugging in your H from your vertex. And then we're going to solve for A and then rewrite the equation. So it'll make more sense when we go through it. So here's an example. We have our vertex, so I like to always label all my points. So we have H, K, X, and Y. Now remember, we're working with A times X minus H squared plus K. So your X will be 3 and Y will be 8. Your H is 2 and your K is 3. So I'm going to rewrite this full equation. So we have, that should be an 8. 8 equals A. We don't know A yet. That's what we're trying to find out. 3 minus 2 squared plus 3. So now we're just going to solve this equation. So this is why we worked so much on solving equations. So we have 8 equals A times 3 minus 2 is 1 squared plus 3. We would do our 1 squared next, so we just get 1A plus 3 equals 8. And to solve this, we subtract our 3. So we find out A equals 5. So now we're going to use this A equals 5 and our vertex to write our equation. We don't need this coordinate anymore once you find A. So our new equation is y equals 5, because that's A, times x minus 2 squared plus 3. So I wanted to point out that I said before your h is always opposite sign because of this. So right here it's minus 2 since this is a positive 2. Here we have our h, k, x, and y. So if you use A times x minus h squared plus k, then our A is what we're solving for, y is negative 4, x is negative 5, h is negative 3, and k is 0. So we're going to plug all this in. So we have negative 4 equals A times negative 5. But see, now we have minus a negative, so it's plus 3, or just the opposite sign of this. Squared. And then we have plus 0, so you don't even have to write that. So we have negative 4 equals A times negative 5 plus 3 is negative 2 squared. Negative 2 squared is negative 2 times negative 2, so it becomes positive 4. So we have negative 4 equals positive 4A. Divide by 4. So we get that A equals negative 1. So now we'll use that. We're done with our coordinate. And we're going to rewrite the equation. So y equals negative, you can write the 1, you don't have to, x plus 3, because again it's the opposite sign, it would be minus negative 3 squared, and there's no plus 0, no plus k. So this is your equation. So you just use what you're given, plug it all in, and we're solving for A, and then using our A and our vertex to write our equation. So next we're going to work on converting vertex form to standard form. So I believe this is easier than converting standard to vertex, so we're starting here. We're going to multiply this out because x minus h squared is the same as x minus h times x minus h. We're going to multiply that out, then distribute in our A, and then add the k and combine like terms to get it to standard form. Whoa. Okay, so first example, So we have y equals negative. I always just rewrite it as x minus 1 times x minus 1. Copy everything else down. Now we're going to multiply out our binomial. So you know we have x squared minus x, so minus 2x, and plus 1. I always keep that in parentheses because you still need to multiply your a by all of that. So your next step, you want to distribute in this negative 1. So we get y equals negative x squared plus 2x minus 1 and minus this one. Make sure you bring this down the entire time. And your last step is to just combine these constants on the end. It'll always be just these two that you need to combine. So we get y equals negative x squared plus 2x minus 2. And now it's in the standard form of ax squared plus bx plus c. So we're going to look at another one of these. So again, I always rewrite it x minus 2 times x minus 2. You can skip this step if you want. Now I multiply them out, so we get x squared minus 4x plus 4. Don't forget to bring down your plus c on the end. Then distribute in this 2. So we get 2x squared minus 8x plus 8, and this is the step where your parentheses can go away. And your last step is to just combine your two constants. So we get y equals 2x squared minus 8x plus 5. And that's the end. So now converting standard form to vertex form, you might have heard before completing the square. I think this is the hardest out of the three concepts in this video, so make sure you're paying attention. So we're going to just go through all these steps with the examples, and we'll practice a lot in class. Don't worry. So whenever you have this, your first step is to always take this plus c on the end and subtract or add it, depending on what it is, to the left side. So since this is plus 15, we're going to subtract 15 from both sides. So your first step is always to isolate your variables on the right side. So now we just have terms with variables in it. Your second step is to check if you have a leading coefficient that isn't 1. In this case, we don't, so I'm not going to go over that until the next problem when we will have one. So your next step, you want to find the term that adds here to make this a perfect square. So to do that, you take this value, you can ignore the sign, just always take the positive, and do off to the side, you're going to do that b, so this is your b term, over 2, and square it. And that's always what you're going to add on to here. So in this case, we have 8 over 2 squared. 8 divided by 2 is 4, so we have 4 squared, which is 16. So that's what we want to add on, but we're going to add it to both sides. Because if you add it to one side, you have to add it to the other. So I'm just going to rewrite it. So we add 16 to this side and 16 to this side. Your next step, now that you added that, this is going to be a perfect square. Like you're able to factor it into a perfect square. So it's going to be x, whatever sign is here, bring it down. And whatever number you squared is what goes here. And you can always double check by multiplying that out. So like x minus 4 times x minus 4 gives you x squared minus 4x plus 16. So it's x squared minus 8x plus 16. So it works. But it's always b over 2 right here. Equals, combine these together. So we have y plus 1. And your last step is to move this back to the side because we always have that term on the end. So we have y equals x minus 4 squared minus 1. So the only time you're going to have an a value is when you have something in front of your x squared here. So we're going to do another example, but you're following these same steps every single time. Now this one has a leading coefficient that isn't 1, so it is going to be a little bit different. But we start off with the same step, subtract 2 to the other side because we want our variables to be alone. So we have y minus 2 equals 3x squared plus 18x. Your next step, so this is where it's different, you need to factor out whatever is here. So essentially you're writing your 3 in front and divide both of these terms by 3. So we just get x squared plus 18 divided by 3 is 6x. Next, we're still taking this 6 and doing the b over 2 squared. So we have 6 over 2 squared, which is 3 squared, which is 9. So we want to add 9 to both sides, but the thing that's different here, so I'll start writing. We're adding this 9 on the right side inside the parentheses, which means that it's being multiplied by this 3 as well. So you're going to add to this side your 9 times whatever you factored out. In this case, it's 3. Then we want to factor this. So again, it's it's x, bring down the sign, and it's whatever you squared here, so 3. Bring down everything else. 3 times 9 is 27. Copy down everything else. So on the right side, if we combine these, we have y plus 25 equals 3 times x plus 3 squared. And your last step is to move this constant over. So we would subtract it. So we get y equals 3 times x plus 3 squared minus 25. So when you have a leading coefficient, your only two differences are this step right here where you have to factor out your leading coefficient, and right here where whatever you add to this side, you need to multiply it by your leading coefficient on this side. So we're going to practice more of this in class, but these are the steps we're following every single time. So the more you practice, the better you'll get. Come to class with any questions you have.